Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra I class. Today we are going to reach the culmination of quadratic functions and equations. So far, just to give you a little brief overview, okay? Remember that we can solve quadratic equations in a few different ways that we have learned. We can go ahead and graph the equation. And when we graph it, the solutions are clearly marked. They're the x-intercepts. Those are called the zeros, or the solutions, or the x-intercepts. And sometimes they're called the roots. Okay? You can graph it and find the solution. You can go ahead and factor when factorable. Let's see, let's go plus 5x plus 4. Okay, I can go ahead and factor this, use the zero product property, set each factor equal to 0, and x will equal -1 and -4. In this case, remember, what that means is that at -4 and at -1, you have two solutions. You can do that. You can also use the square root property if it's in the right format. If you have y equals x squared minus, I don't know, 20, actually plus 25. No, I was right with the minus. Y equals x squared minus 25. I can add 25 to both sides, make y 0, so 25 equals x squared. Cancel out a power of 2 with a square root, and x will equal plus or minus 5. Again, what that means is that at -5 and +5, I have two solutions, right? Okay, great. So we have a lot of tools in our chest here. Now, today we're going to learn about the quadratic formula. And the quadratic formula is absolutely by far the most powerful of all ways to solve quadratic functions. I did not say it's the easiest. I said it's the most powerful. And it is the most powerful because the beauty of the quadratic formula is that it does not matter what your function looks like. It doesn't matter if you have fractions or decimals, if it's factorable, if it's not factorable, if you can use the square root method or if you can't use the square root method. You can solve any kind, and I mean any kind, of quadratic equation or function with the quadratic formula. In fact, you could use the determinant, which we're going to talk about in a second. The determinant is part of the quadratic formula. You could use the determinant to find out how many solutions you're going to have before you even start solving. So it's a very powerful formula. Now, in order to solve any quadratic equation, okay, ax squared plus bx plus c equals 0, you can use the quadratic formula. Please note, this here is a quadratic function. Y equals ax squared plus bx plus c. When I am solving a quadratic function, I'm finding the x-intercepts. Think about the definition there. The x-intercepts are the x values when y equals 0. So this y becomes a 0. And that's why it becomes a 0. Now, the a, my friends, belongs to the x squared. Please, that will never change. The coefficient of the x squared is a. The coefficient of the x alone is b. And the number all by itself is called the constant. That's c. In order to use the quadratic formula, you must write the function in standard form. Just like when you're factoring it. Just like when you're using the square root method. Just like when you're graphing it. Anytime you want to solve the quadratic function, whether you're using the quadratic formula, square root method, factoring method, or graphing method, you got to solve for y. You got to put it in standard form. And the quadratic formula is very simple. It's negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. That is the formula. This will be used in geometry, I promise. In Algebra II, I promise. Not so much in trigonometry. In college algebra, I promise. Math analysis, pre-calculus, and calculus. Those are all maths you're pretty much going to take, guys, because I know you guys are going to go and want good careers and go to college. It's pretty much what you're going to have to take with you. So learn it today. Learn it now. Keep it part of you so you could use it for the rest of your mathematical career. Let's see how it works, boys. What are the solutions of, and I got 2x squared minus x equals 4. First thing I'm going to do is subtract 4 to both sides so I can have it now in standard form. And I set it equal to 0 always because, again, I'm looking for the x-intercepts. I'm looking for the solutions. So the x-intercepts are the x values when y equals 0. Let's do this. Always label what your A, your B, and your C are. Always label what your A, your B, and your C are. It's going to make your life easier, I promise. So A equals 2, B equals -1, C equals -4. Now, literally, my friends, just plug it into the formula. Mr. Moore, what's the formula again? It's negative b plus or minus the square root of b squared minus 4 times a times c over 2a. So let's plug it in. Negative times the value of b. B is -1. That's why I put it in parentheses. And not equals. Come on. It's not equals. Plus or minus square root of -1 in parentheses squared minus 4 times a times c over 2a. 2 times 2. That's what we got. And now it's a matter of doing the numbers. Please remember, simplify the radical as much as you can. Remember, we already learned how to simplify radicals in the square root method. You are not going to be allowed to use a calculator. I repeat, you are not going to be allowed to use a calculator. So you have to reduce the radical to simplest terms. So what do we get here? Negative times a -1 is 1. Plus or minus the square root of -1 squared is 1. Okay, so you have 1. -8 times a -4 is 32. So 1 plus 32 is 33 over 4. And that's my answer. Can I break down 33 so that I can pull out a perfect pair of numbers? No. 33 breaks down into 11 times 3. Do I have 2 11s? Do I have 2 3s? So can I take anything out of the radical? So I am done. Now, what does this plus or minus indicate again? You have 2 solutions here. You have 1 plus the square root of 33 over 4, comma, 1 minus the square root of 33 over 4. That's what that plus or minus means. Does that make sense, gentlemen? All right, let's continue. X squared plus 6x plus 9 equals 0. What's my A? 1. What's my B? What's my C? Okay, so negative B plus or minus square root of B squared minus 4 times A times C over 2 times A. This equals -6 plus or minus the square root of 36 minus 36 over 2, which equals -6 plus or minus 0 over 2. 0 cancels. So my answer is x equals -3. In this particular case, you have one solution at 3. One solution. Does that make sense, gentlemen? Talk to me, please, guys. It's the last section of the chapter. I want you to end strong. We got this? All right. Let's do it. Next. What do I have to do first here for C? Yes, you have to first put it into standard form. Thank you. So I got x squared plus 4x plus 4. Negative b plus or minus square root of b squared minus 4 times a times c over 2a. That's going to equal negative 4 plus or minus 16 minus 16, again, is a 0 over 2. So x equals negative 2 in this case. So in this particular case, again, you just have one solution. For D, all right? For D, let's label. What's my A? What's my B? What's my C? Negative 3, good. B squared, negative B, plus or minus B squared minus 4 times A times C over 2A. That's going to equal negative 4 plus or minus 4 squared is 16. Negative 4 times 1 times negative 3 is positive 12 over 2, which will equal negative 4 plus or minus square root of 28 over 2. Are you guys with me so far? Now, I cannot finish yet until I have simplified that square root of 28. And the square root of 28, if you think about it, breaks up into 4 and 7. 4 is a 2 and a 2. So this will turn out to be negative 4 plus or minus 2 square root of 7 divided by 2. Because I had two 2's, so I pulled out a 2, and I had a radical 7 left over. And unfortunately, guys, we're not done yet. What else can we do here? Very good. 2 is divisible into 4 and this 2 as well. So this 2 will be divided to this guy, and this 2 will be divided to that guy. Not to the inside of the radical, but for the outside 2. So in the end, this will equal negative 2 plus or minus square root of 7. That is what I'm looking for, my friends. That is what I'm looking for, my friends. All the way simplified. Does that make sense? Yes, no, maybe, kind of, sort of? Okay. May I continue? Okay, thank you. All right. So now, what is so special about this word that I said in the beginning, the discriminant? Well, the discriminant of a quadratic equation, okay, or function in the form of ax squared plus bx plus c equals 0, is the value of the expression b squared minus 4ac. The inside value. That is called the discriminant. And what the discriminant tells you is how many solutions that quadratic function is going to have. It does not tell you the solutions. In order for you to find the actual solutions, my friends, remember, you must use the complete formula. But let's say you're on a big test, okay, and time is of the issue. And you look at this and you say, I don't even think there's going to be a solution. I think there's no solution here. You can plug in the values into the b squared minus 4ac, and in seconds, immediately find out if there's 1, 2, or no solutions. Let me explain how this works. When you plug in the values into the b squared minus 4ac, you don't have to worry about the square root. You don't have to worry about this over here. You don't have to worry about this over here. When you're trying to determine how many solutions a quadratic function has, all you've got to use is the discriminant, which is b squared minus 4ac. How does it work? If b squared minus 4ac equals 0, you have one real solution. Real quick, you guys notice, what was the discriminant here? What was the discriminant here, guys? Okay, you're telling me 36, but 36 minus 36 is not 36. 0. How many solutions did I have? See what I mean? Okay, so when the discriminant equals, bless you, equals 0, I have one and only one solution. Right there. If the discriminant b squared minus 4ac is greater than 0, you're going to have two solutions. I promise. And if b squared minus 4ac, the discriminant, is less than 0, then you have no real solutions. That means that the graph never touches the x-axis. So if the discriminant is greater than 0, two solutions. If the discriminant is equal to 0, one solution. If the discriminant is less than 0, no solutions. So for example, what is the number of solutions, of real solutions of each equation? What's my A here? Because it's already in standard form. What's my B? What's my C? Okay. In order to find out the number of solutions, again, you're not finding the solution. To find the solution, you use the complete quadratic formula. But to find how many solutions I have, the number of solutions, I'm going to use my discriminant, b squared minus 4ac. So b squared, negative 3 squared, minus 4 times 2 times 7, that's 9, minus 56, right? Because 4 times 2 is 8 times 7, 56. That's going to be negative 47. So how many solutions do we have here? None. No solutions. If my discriminant is less than 0, there are no solutions. You're done. B. What do you think I'd have to do first for B? Thank you. Put it in standard form. So let's subtract the 6x and the negative 5 to both sides. And I got x squared minus 6x minus 5 equals 0. Let's find out how many solutions they got. What's my A? 1. Good. What's my B? Yes, excellent. What's my C? Excellent. So B squared minus 4 times A times C. That's 36 plus 20. That's positive 56. How many solutions? It's greater than 0, so how many solutions? 2 solutions. Now, if you want to find the actual solutions, you got to plug everything into the complete quadratic formula. Does that make sense, my friends? Yeah? Yes, no, maybe, kind of, sort of. Yes? Okay. Thank you. Now, let's put solving quadratic functions together. I did this in the beginning. I want to wrap it up again. You have learned several ways to solve quadratic function and equations. When do you use each method? This is important to know, right? First method, graphing. Okay? When you're graphing, you use graphing if the equation is very easy. I'm talking really easy. Like, if you have y equals 2x squared, that's a great one to graph, because that's really simple. The axis of symmetry is 0. The vertex is 0, 0. Plug in one value for x, find the mirror image, you're done. When do I use the square root method? I use the square root method when the equation does not have a bx term. if I have an equation in the form of, let's say, whatever, 2x squared minus 98, I'm going to use the square root method there. I'm going to add 98 to both sides, divided by 2. X squared will equal 49. Take the square root of both sides. X will equal plus or minus 7. Factoring. Use factoring if the equation is factorable. Okay? This may be the most common. You could usually factor most quadratics that they're going to give you. Remember the Cuban method for that, okay? Don't forget that. Now, completing the square, you'll talk about completing the square in Algebra II. We went ahead and skipped that for this year. But it's not a big deal because the quadratic formula is even more powerful than completing the square. The quadratic formula you use if the equation is not factorable and a is greater than 0. Basically, when you got the ugly stuff, I mean greater than 1. No, I'm sorry, not 0. And actually, this part is false. You know what? Because you can have a fraction. It's just when the equation is not factorable. If I gave you something nasty like this, 2x squared minus 7x plus 86, you really think you're going to want to factor that? Guys? Yeah, no, I don't either. Okay, so I'm going to use the quadratic formula. If they gave you something like 3/5 x squared minus 2/3 x minus 7/8, oh goodness, I do not want to factor that. I don't even really want to use the quadratic formula either for that because it's going to be ugly, but that's how you would do it, okay? So when they're really ugly, you use the quadratic formula. All right, my friends? All right, so which methods will you use to solve each and why? Okay, number 1, what do you think we would use here? Square root y. Because there is no bx, very good. So I would add 9 to both sides. 3x squared equals 9 divided by 3. X squared, equals 3. Square root both sides. X will actually equal plus or minus square root of 3. Done. Done. I use the square root method. Why? Because there was no bx. Okay. For number 2, what do you think, guys? I'm going to go quadratic formula. Absolutely. Why? It's ugly. It's got large numbers. I don't know if that's factorable or not, and it's going to take me a long time to find out. So why are we going to fight? Let's just go ahead and fix the problem. Negative b plus or minus square root of b squared minus 4 times a times c over 2a. All right, so what's that going to give me? It's going to give me negative 13 plus or minus, I got 13 squared, which is 169. And then I got 4 times 6, which is 24. And 24 times 17, we got 8, 2, 16, 4, 2, 8, 0, 1, 408. 408 plus 169. That's 717, 577. Okay, so that's 577 over 12. Easy peasy. Done. Does that make sense? Yes, no, maybe, kind of, sort of, guys? Here to help you. Remember that. I'm here to help you. Sir, thank you. Okay, good question. My boy just asked, can I break up 577? Well, it's not divisible by 2. 5 plus 2 is 5 plus 7 is 12, plus another 7 is 19, so it's not divisible by 3. It's not divisible by 4. It's not divisible by 5. It's not divisible by 6. 7 is not divisible. 8, no. 9, no. 10, no. Done. Leave it like that. You always go through your divisibility tests. That's how you're going to know if you can break it down. Thank you so much. Okay, how about 5? Number 5. Which way do you think we would do? Come again, guys? I'm sorry. Why am I going 5? Hello, Mr. Morrow. Number 3, yes. What do you think? Oh my goodness, yes. Look how ugly these numbers are. Quadratic formula. A is my negative 16. B is my negative 50. C is my 21. B, negative B plus or minus B squared minus 4 times A times C over 2 times A. So this is going to be 50 plus or minus square root of 50 squared is 2,500. And then plus negative 4 times negative 16 is 64. 64 times 21, 6, 4, 8, 12, 4, 4, 1, 3, 1,344. So let's add them together right now. 2,500 plus 1,344 is 2,844 over negative 32. Now, for time's sake, we're going to move on. However, you can break that down. You can. It's even, isn't it? So you can start breaking it down immediately. Okay? For sure, we know that 4 goes into it because the last 2 digits of the number are divisible by 4. So I'm not going to break it down now, but you would have to break this down on the test. How about number 4? Which method do you think we would use here? No, it's not quadratic formula always, guys. Factor, yes, always try to factor because factoring is so much easier than anything else. 1 times 1 is negative 30, but when added together is negative 1. Okay, which sign? Negative 6, positive 5, very good. Set both of these guys equal to 0, so x will equal 6 and negative 5. Bingo. If you can factor it, my friends, factor it. Okay? Because the quadratic formula is beautiful and I love it. But it's longer than just factoring it if you can. How about number 5? Okay? Now you guys are just saying factor because I think that's what you want me to hear you say. I want you instead to think. 1 times 1 is 3, but when added together is negative 5, friends. Nothing. So don't just say factor because that's what you think I want to hear. I want you to analyze each one and think. This is not factorable, so we're going to use the quadratic formula. A equals 1, B equals negative 5, C equals 3. So negative B plus or minus B squared minus 4 times A times C divided by 2A. That's going to equal 5 plus or minus 25 minus 12 is 13 over 2. And no, 13 cannot be factored. Last but not least, number 6. I would use a square root method for sure. There's no bx. X squared equals 49 1/44. Square root both top and bottom here, and you get plus or minus 7/12. And my friends, that is how you solve quadratic functions. Thank you very much. I hope you learned a lot, and have a wonderful day.